Good day, everyone. Today, I will be presenting to you an experimental and informative video on the topic work. But first, what is work? Okay, when we talk about work, work is done whenever a force moves something. And in our everyday example of work include walking upstairs, lifting heavy objects, pulling a sledge, and pushing a shopping trolley. Wherever a work is done, energy is transferred from one place to another. Before moving on to our problem experiment, in line with the topic work, I will be playing first some videos wherein we can see that work is applied in our day-to-day experiences. For our first video,
As we can see in the first video, the girl is carrying boxes, and carrying those boxes, we can clearly see that the work in force is applied in moving that boxes from one place to another. The second video. Now, in this video, we can see that the girl is using force in moving that heavy plant to another place. It is a simple scenario where a work can be seen. Now for the next video, the boy is using force in pushing that wheelbarrow that approximately weighed more than 10 kilos. From just moving that wheelbarrow, we can clearly see that the force is applied. Hence, work can be seen in that scenario. Our fourth video, we can observe in this video that the moment the girl pick up the heavy shoulder bag and run on the stairs, work is done since force is used in carrying and traveling that bag. Now for our last video, in our last video, we can see that the girl is moving back and forth while carrying heavy objects. We can simply see that the work is present in that scenario, since the girl used force in lifting those objects and transferred them from one place to another. That's all for the real life application of work.
now let's move on to our experimental problem in line with the topic work.
Marla is sitting nearby a bus station. Looking on the cars and buses passing by, Marla imagined the car that is going to bump in the convenience store in a speed of 25 meters per second. Marla contemplated how much work is required to stop a 1,500 kilogram car moving at a speed of 25 meters per second.
Before moving on with our solution or the solving of our problem, let us first hear our statement of the hypothesis. In physics, work is the energy transferred to or from an object via the application of force along a displacement. In its simplest form, it is often represented as a product of force and displacement. Now, the hypothesis is that there is a possibility to witness a negative kinetic energy as the car comes to a stop. And we will be finding out later if our hypothesis is approved or rejected after seeing the solving or solution.
The work net is equals to delta TE. Always remember that the net work is equal to the change of kinetic energy of an object. Now, the work net is equals to the final kinetic energy minus the initial kinetic energy. The force that is stopping the car is equals to the net force acting on the object. Now, the work net is equals to 0 minus the initial kinetic energy. A car comes to stop, the final kinetic energy is 0. The work net is equals to negative 1/2 meters times the velocity raised to the power of 2. To substitute, we have here the work net is equals to negative 1/2 times 1,500 kg for the mass of the car times 25 meters per second for its speed. So now our final answer will be work net is equals to negative 468,750 joules. The reason why it's negative because the car's kinetic energy is decreasing as it comes to a stop.
After seeing the solution of one of our members, we can now conclude that the hypothesis we mentioned earlier is approved, since we can see that when the time the car comes to a stop, there is a decrease in its kinetic energy. That's all for our experimental and informative video. We hope you learned something from what we present.